Our solar system is a fascinating place. It's filled with diverse planets, each with its own story. But there's one celestial body that reigns supreme: Jupiter. This gas giant is a behemoth, dwarfing all other planets in our solar system combined. Jupiter's gravitational pull is so strong that it has profoundly shaped the solar system's architecture. It has shepherded asteroids, captured comets, and even influenced the orbits of its planetary siblings. Jupiter is more than just a big planet, it's a testament to the raw power of nature. It's a swirling vortex of gas and dust, a place where storms rage for centuries. The Great Red Spot, a giant storm system larger than Earth, has been active for hundreds of years. Jupiter's sheer scale is hard to comprehend. Its volume is so vast that you could fit 1,300 Earths inside it. If you were to stand on Jupiter's cloud tops, not that you could, you would witness a breathtaking view of swirling clouds and lightning storms. Jupiter is a constant reminder of the vastness and mystery of our universe. It's a place of extremes, where temperatures and pressures reach unimaginable levels. As we explore the cosmos, Jupiter serves as a benchmark, a giant against which we measure all other gas giants. It's a reminder that our solar system is just a small part of something much grander and more awe-inspiring. Jupiter's composition is a captivating mystery. Unlike rocky planets like Earth, Jupiter is primarily composed of hydrogen and helium. These light elements, the most abundant in the universe, give Jupiter its massive size but surprisingly low density. Deep within Jupiter's atmosphere, pressure and temperature increase dramatically. This creates strange states of matter. Hydrogen, normally a gas, transforms into a metallic liquid. This exotic substance is thought to be responsible for Jupiter's powerful magnetic field. Jupiter's magnetic field is a force to be reckoned with. It's the largest and most powerful magnetic field of any planet in our solar system. This invisible shield extends millions of kilometers into space, trapping charged particles from the sun and creating intense radiation belts. These radiation belts are so powerful that they can damage spacecraft. Jupiter's magnetic field is not just a shield, it's also a source of stunning auroras. These auroras are like the northern lights on Earth, but on Jupiter, they are hundreds of times more energetic and larger than our entire planet. Understanding Jupiter's composition and magnetic field is crucial for understanding the formation and evolution of gas giants. By studying Jupiter, we gain insights into the processes that shaped our solar system and other planetary systems throughout the universe. Jupiter's secrets, hidden beneath its swirling clouds, hold the key to unlocking some of the biggest mysteries of planetary science. In the vast expanse of the cosmos, far beyond our solar system, lie planets that defy imagination. Among them are the young Jupiters, massive gas giants that make even Jupiter look small. These celestial behemoths are still glowing from the heat of their formation. They emit infrared radiation, making them visible to our telescopes. Young Jupiters are like cosmic teenagers, still undergoing growth spurts and experiencing intense internal heat. What sets these young Jupiters apart is not just their size, but also their environments. They orbit incredibly close to their host stars, much closer than Jupiter is to our Sun. This proximity results in scorching temperatures, often thousands of degrees Celsius. These planets are locked in a gravitational dance with their stars, with one side perpetually facing the searing heat. This creates extreme temperature differences between their day and night sides. Studying young Jupiters provides a unique opportunity to observe the early stages of planetary evolution. These planets are still shaping their surroundings. Their gravitational pull influences the formation of other planets and the structure of their planetary systems. By understanding these young giants, we can piece together the history of our own solar system and the processes that led to the formation of Earth. When it comes to planets, size isn't everything. While young Jupiters might dwarf Jupiter in size, they don't necessarily outweigh it. This is because mass and size aren't always correlated in the realm of gas giants. Think of it this way. Imagine a giant balloon and a bowling ball. The balloon might be much larger, but the bowling ball is significantly heavier. The same principle applies to planets. Young Jupiters, despite their impressive girth, tend to be less dense than Jupiter. This is because they are hotter, and their atmospheres are more expanded. Jupiter, on the other hand, is denser and more compact. It's like comparing a fluffy cloud to a tightly packed snowball. Both might be made of water, but their densities are vastly different. This difference in density highlights the importance of considering both mass and size when studying planets. Mass tells us about a planet's gravitational pull and its influence on its surroundings. Size, on the other hand, gives us clues about its composition and its atmosphere. By studying both, we get a more complete picture of a planet's characteristics and its place in the cosmic order.